Continuing on now from the last video where we had successfully used a standard dictionary attack to find the passphrase of a wpa2 PSK protected access point. We will explore with Wireshark and take a look at the capture file. Remember that in our last video we had captured a four-way handshake. So let's take a look at what that looks like with Wireshark. And let's open the file. New 2 was where we were in new 2. And this was the file that we wanted to look at. It's a small capture file because we didn't really capture a lot, and then we got that handshake already. Let's open it. So these are the frames that were captured when we were trying to get the four-way handshake, and finally AeroDump NG told us that we had managed to capture a four-way handshake. The problem now is how we find the four-way handshake among all these frames, and we can go through one by one and slowly eventually find the frames. But let's take advantage of the filtering capabilities of Wireshark to do that for us. The four-way handshake is not using 802.11 but EAPOL. So we can do this. That's Extensible Authentication Protocol over LAN, so EAPOL. And Wireshark helps us by showing that we have message 1 of 4, message 2, message 3, and message 4. So we can see the messages here. And we can open to take a look at the values like the nonce, A nonce, S nonce, and so on that are inside. So that's message 1, message 2, message 3, and a message 4. Now let's just remove this filter so we see these messages. With other frames around them. So we see these 4 EAPOL messages, which are the handshake, and we see other messages around as well. So one thing that we notice is that we did not provide Wireshark with the WPA PSK. So we didn't provide it with the key or the passphrase, and it was able to view these handshake messages. And if we think about it for a moment, it makes sense because these handshake messages are being exchanged in the process of the client and access point trying to come up with a shared key that they can use. They're not going to use the pre-shared master key, remember. So they're trying to derive a key that they can use for encryption. So if these messages are already encrypted, that's going to be a problem. Clearly, these should not be encrypted until the shared secret is set up, and then other messages can be encrypted. So therefore, we see things like probe requests. It makes sense. Probe requests, that's before you associate, before you do anything. How will the client be able to see encrypted responses? And it doesn't make sense for the client to send encrypted probe requests. So these are also in plain text as well as the EAPOL. That's why we were able to inspect them without having to let Wireshark know the pre-shared key. Not all the frames are sent in plain text though. So let's take a look at something that is encrypted, and we will need to provide Wireshark the key in order to see. That way we can see the difference between frames like these handshake frames and other data. So for example, ARP request. So like this one here, broadcast, we see it's encrypted, so we don't know what it is, at least until we tell Wireshark what the key is. Since we have retrieved the key already, well, rather we guessed it, so we can go put this in. And edit it. Previously we had entered this WP key, but now it's a different kind of key. We see that there's two for WPA. One is WPA password and the other is WPA PSK. So PWD is used when we want to enter a passphrase. And WPA-PSK is the actual key itself, which is in hexadecimal, and we don't know it. Well, we can always use a piece of software to go derive it from the passphrase that we know. But since we know the passphrase, let's just enter it here. And now, so remember that we were seeing this broadcast message. It was just like data, and Wireshark didn't know what it was. So we did not move our cursor, but now we see that suddenly the display looks more informative. So now we see that the frame that we had selected previously was a DHCP frame. So DHCP discover, which was broadcast, and then we see things like ARP. So these things that were just data before and Wireshark didn't know how to interpret them, now we see that Wireshark knows how to interpret them because it has the WPA passphrase.